So, from the Rose Garden in Duluth, let's travel up the shore to Glensheen Mansion. Glensheen is owned by the university, and it's just a spectacular property right on the lake shore with great concerts on Wednesday nights. Their website is glensheen.org, and I think the website speaks for itself. The mansion, spectacular. The grounds, amazing. Truly a wonderful spot to be. And in such an elegant spot, it's time for us to consider a little bit about how to start writing elegant code. And the key to writing elegant code is knowing how to use control structures. We'll learn the first of those today as we talk about branching. Okay, today we talk about branching statements, probably one of the most powerful tools we have this semester to solve problems. A branching tool is a control structure. It controls the flow of information through the program. Sometimes branching tools are called selection structures because they select between alternatives. Sometimes they're called if statements, but they're way more than that. An if statement is just one example. Let's take a look at some of these things. And here's a typical situation in which you might need one. An employee's gross pay is computed as their hourly rate of pay times the number of hours they worked. But some employees might work overtime, and in that case, they get an extra amount. They get their normal rate for the first 40 hours, and then they get time and a half for all the hours that they worked above 40. So here you see formulas for regular pay and for overtime pay. And we have to choose in our program which one we're going to run. We'll ask the employee how many hours they worked, and if the number of hours is over 40, we'll have to use the second formula, and if it's 40 or less, we'll use the first. So how do we decide if their hours is greater than 40? We'll have to look at the hours, make a decision, and basically that involves looking at what we call a condition, or sometimes it's known as a Boolean expression. Is the hours greater than 40? That's either true or false. That's what makes it Boolean. We've seen Boolean data storing the value true or false. This is a Boolean expression. It boils down to one or the other. And if the expression is true, then we calculate it one way, and if it's false, we calculate it another way. And this is what an if statement would look like to do that. If the hours are greater than 40, hours greater than 40 is the Boolean expression, then calculate the gross pay, giving them time and a half for all the hours over 40. Otherwise, calculate their gross pay the normal way, just multiply rate times hours. Usually, if statements give you a little more room to put other commands in. So these curly braces define the body of the true and the false portion of the if statement. If the hours are greater than 40, we've got a place to put the calculation for gross pay and any other commands we want. Similarly, if the hours are less than or equal to 40, that's the else clause, then we have a place to put all the statements that apply in that situation. Your book has many examples of this type of stuff. Here you see in blue, they've done a very simple one that says if the hours are greater than 40, calculate it one way, otherwise calculate it the other way. And this is how you normally see in computer programs decisions being made with if statements. I mentioned that Boolean expressions are the things that we're looking at. They're either true or false. A Boolean expression uses a comparison operator. Greater than or equal to, less than or equal to, not equal to. Those are the comparison operators. So we should know those really well. And here they are. The math symbols that you're familiar with are down the left-hand side. The C++ notation is that middle column, and you can see they're not always the same. For example, if I want to say is equal to, I use two equal signs. And you may wonder, why do we do that? Because we've already used the operator a single equal sign to stand for assignment. Remember that? We use that all the time. So we can't get them confused. The compiler needs to know what's happening. So if we want to say is equal to, we put two equal signs next to each other. Not equal to uses an exclamation mark and then an equal sign. And the rest are kind of what you'd expect. Less than and greater than are normal. Less than or equal to and greater than or equal to have the less than sign and then an equals, or the greater than sign and then an equals sign after it. And here's where we put these operators in our operator precedence table. Now remember, these are sometimes called comparison operators. Your author uses that term. Oftentimes they're also referred to as relational operators because they compare relationships between things. But either way, in the operator precedence table, the operator hierarchy, they fall after arithmetic operators. You do all the math first, and then you compare things. And we can compare them using less than or equal to, greater than or equal to. Those happen first. And the other two equivalence comparison operators, equal to and not equal to, have a lower level of precedence. Okay, I've got a little sample program here with an if statement. This program is nasty. There's something terribly wrong with it. Take a quick look at it and see if you can figure out what that might be. Okay, what do we do in this program? We enter a character variable, so the user types in a character, and then we look at it to see if it's the letter A, and if it is, we print out this is the letter A. And if it's not the letter A, we print out this is not the letter A. At least that's the idea. But when this program runs, it doesn't work that way. Take a look at the output. We asked the user here to enter the character A. They typed that in, and it printed out this is the letter A. Next time we ran it, we asked the user to enter a character, and they typed in X. And the computer said A. This is the letter A. Next time we ran it, we asked them to enter a character, and they typed in a question mark, and the computer said A. This is letter A. Apparently every single thing the user types is going to be considered to be an A. And so where did we go wrong here? What in the world happened? And the answer to that is very, very devious mistake. In the if statement, putting one equal sign in, remember, is assignment. It takes the thing on the right and puts it into the location on the left. So that if statement says put A into your character variable. So whatever you typed in previously is now gone. We shouldn't have had an assignment operator there. We should have said is equal to, and that's two equal signs. So be very careful when you do this. Once we've done that, then this works exactly as you'd expect. If they type in A, it says it's the letter A. If they type in X or question mark, it says it's not the letter A. Perfect. Now I've got a couple of if statements here, and if you take out a piece of paper, see if you can rewrite the following if statements so that we don't have two separate if statements. Instead, we have the kind of if-else form. Give that a shot. You should have something kind of like this. If the data was greater than 100, print too large, otherwise print just right. The second form is much preferable to the first. The first forces two decisions to be made. Is the data greater than 100 And once that's done, is the data less than or equal to 100? And honestly, we can get by with only having to do one of those statements if we write it correctly, and that's what you see below. Let's say the data value was 150. In the first two if statements, you'd get 150 greater than 100 is true, and then you'd print something out. Then you'd go to the next line and say 150 is less than 100. Oh, that's false. Well, why are we even there? We already know the answer. And the second form of this if statement helps us get around the problem. If the data 150 is greater than 100, we print too large and we skip the second part and never look at it again. We don't have to do two comparisons here with the data, just one. You've already seen the use of those curly braces. Again, I'd like to make the point that you should probably put those in every if statement you write. If you leave them out, you'll sadly discover that you can only do one true statement or one false statement. And oftentimes we just need more than that. Here's your author's example of a place where you've got several statements inside of each part of an if statement, the true part, the false part. Thanks for watching.